Video lecture 3.5 is subtropical high pressure. So coming out of the subtropical high pressure in both the northern and southern hemisphere, we have these arrows. And if you look at the one in the northern hemisphere, that they're around roughly 20 to 30 degrees north. We can see that the winds come out of the subtropical high pressure, but then those winds then go into the equatorial low pressure. And so if we can think about the general direction of those arrows, they're going from the northeast to the southwest. And so the dominant wind pattern we would expect to find in the subtropical high pressure in the northern hemisphere, coming out of it, going to the south, would be northeast winds. Once again, winds, we refer to them as the direction they're coming from. So we can see this northeast wind pattern coming out of the southern side of the subtropical high pressure in the northern hemisphere. Now, the southern hemisphere coming out to the north, causing the southern side of the equatorial low pressure to have that converging air, we have what we would refer to as southeast winds because they come from the southeast and go towards the northwest. The subtropical high pressures are created when that Hadley cell, we talked about when that dry air descends after it's essentially spewed out all of its moisture there in the equatorial low pressure zone. These overlap with the Earth's deserts. The Kalahari, the Sahara are all found and dominated by subtropical high pressure zone areas. Here, once again, this is not a thermal. It's not strictly because of temperature which causes this high pressure. It's more mechanics, physics at work. I'm not going to go too much into that. And so we refer to it as a dynamic high pressure, not a thermal one because it's not directly caused by heating and cooling like what we find there at the equatorial low pressure, but then both of the polar high pressures. Key here, divergence. And so we're going to come out of the high pressure, we're going to have divergence. That makes sense. Once again, going back to what a high pressure zone characteristic is. And so coming out of the southern side in the northern hemisphere of the subtropical high pressure zone is the trade winds. Then coming out of the northern side are the westerlies. And I'll showcase each of those on the following slides. Here's the way to identify the trade winds on this schematic that we've seen beforehand. So the divergence at 30 degrees north and 30 degrees south creates convergence there along the equator at the equatorial low pressure trough. So to the north of the equator you have the northeast trade winds, and to the south of the equator you have the southeast trade winds. And we'll be able to visualize these in various videos that I'll showcase in our discussion. Now going back to our general schematic, we can now name these arrows that are inside the white box, and those are the trade winds. Now as we begin to build out even more so, we can see these westerlies as they're identified here. And they're going to be on the opposite side of the trade winds that come out of the subtropical high pressure. So they're going the other direction. Once again, we're seeing divergence here at 30 degrees south and 30 degrees north with those arrows going away from each other at the surface. Now we can name these purple arrows as the westerlies.